Hello there, welcome to the series of videos going through the content of A-Level Further Maths. Here we're going to see how we reflect a point in a plane so we can answer questions from exercise 9F. So quite a difficult calculation this. Let's get started on a question. So we have a plane which is r.122 equals 5 and we have a coordinate 1, 3, minus 2. The first part in this problem here is just to find the shortest distance between the point and the plane. Now this here is quite straightforward. All you have to do is just apply the formula. So finding the shortest distance between the point and the plane, that it really is quite a simple job, just plugging numbers into a formula. The difficult part of this question comes in when we're asked to reflect the point P in the plane to get to the point Q. So let's draw a diagram to try and visualize the problem. What we have is a plane pi. Coordinate P at the moment is underneath the plane, and what we want is to reflect the point P in a perpendicular straight line distance from P up to Q, which you can see up there. So its midpoint M is going to come in very useful in this question here. Let the midpoint M, which lies in the plane, this midpoint M is effectively going to be the point through the reflection to get from P up to Q, and it's going to lie on the plane. And what we're going to do first is think about how we can get from P to M and then double that distance to get from P up to Q. So there's a straight line going through M from P to Q. And also we're given the fact that this straight line is definitely going to be at a right angle to the plane, and we know what the right angle direction is. That's 1, 2, 2 from the n vector of the plane. So the vector equation of the line from P to Q can be calculated by starting at this coordinate P here and taking ourselves up this line here by a direction vector of 1, 2, 2 up to hit coordinate M, and it can carry on going up to coordinate Q as well. So the vector equation from the line P to Q is going to equal this for some value lambda. Okay, so hopefully that's made sense. This setting up of this equation here is really important to get this question started. The dotted line has a vector equation that starts at 1, 3, minus 2 and travels in a direction of 1, 2, 2. So the vector is going to be 1, 3, minus 2, the starting point, add lambda lots of 1, 2, 2, the direction vector, to get from P straight up to the plane. The reason that we're using this direction vector is because that is the perpendicular to this plane. So the coordinate M can be defined by 1 plus lambda, 3 plus 2 lambda, and minus 2 plus 2 lambda. What we're going to do first is find the corresponding value for lambda to get to M, double that, and then we'll get to Q. So coordinate M is here. The coordinate M also passes through the plane, so it would satisfy that equation too. So what we're going to do here now is we're going to use our coordinate M and substitute that into the equation of the plane, because M does lie on the plane. So substituting in the equation, the coordinate M into the equation of the plane, dot product that out, and we get 3 plus 9 lambda equals 5. Rearrange this equation here, and we get lambda equals 2 over 9. So the value for lambda is going to be 2 over 9 if we start from here and head up towards the coordinate M. So the position M is going to start at 1, 3, minus 2 and go 2/9 up the direction vector of 1, 2, 2. Q is going to be double this distance away from the point P if we compare that to M. This works since we've used P as the fixed point starting the equation of our line. So Q is going to start at 1, 3, minus 2 plus 4/9. So effectively from here to here, that was a lambda value of 2/9. From here round to here now, this is going to be a lambda value of 4/9 because it is twice as far away from M from P. So we can just now calculate this answer here. So do 1, 3, minus 2, add 4/9 of the vector 1, 2, 2, and we get this coordinate down here, 13 over 9, 35 over 9, and minus 10 over 9. Okay, so that's how we do these sorts of questions. We start off by initially setting up a vector that starts at P and goes up towards the plane at M. It goes up in the direction vector perpendicular to the plane. Find the value of lambda by substituting it into your equation of your plane, and then find lambda, double it to reflect the point. Your turn to have a go at a question here. Now feel free to rewind the video and see how this was done again so you can get started on your question, but have a go anyway. Try your hardest on this before I show you the answer. Alright then, let's start to have a go at this now then. So the equation of our plane is going to be r dot minus 2, 1, 1 equals 5. And the coordinate is going to be at 1, 0, 3. So what I think I'll do is I'll start off by drawing a diagram. So I've got my coordinate P here. I've got my intersection point with the plane M here. And I've got my coordinate Q up here. I'd always draw a diagram for this just to help yourself visualize it. So the equation of the line from P to M is going to be starting at the coordinate 1, 0, 3, and it's going to be plus lambda lots of the direction vector that's perpendicular to the plane, that's minus 2, 1, 1. Now we can combine this, so this is the direction vector of the line, so we can combine this into one vector, so it's 1 minus 2 lambda, lambda and 3 plus lambda. And for a certain value lambda, it's going to intersect at M, and for double that value of lambda, it's going to go through and meet at Q. What we want to find out first is the lambda value for M, at which it intersects the plane. So we're going to have to substitute this now into the equation of the plane to work out the lambda value. So 1 minus 2 lambda, lambda 3 plus lambda, dotted with minus 2, 1, 1, equals, expanding the brackets, we'll set this equal to 5 afterwards, so minus 2 plus 4 lambda plus lambda plus 3 plus lambda equals 5. So taking all the lambdas over to the other side, we get 6 lambda equals, well, we're going to add 2, so 7 minus 3, we get 4, so lambda here is going to equal 2/3. That is to get to M. So if we want to get to Q, we're going to use lambda equals 4/3. Because we want to go double the distance from P to Q. So what we're going to do now is we're going to take this equation here and substitute in 4/3. So 1 minus 2 lots of 4/3. So this is where Q is going to be. Then it's going to be 4/3, and then it's going to be 3 plus 4/3. So it's going to be 3/3 minus 8/3, so that's going to be minus 5/3, 4/3, and 9/3 plus 4/3 is 13/3. So this is our coordinate for Q then. It's going to be minus 5 over 3, 4 over 3, and 13 over 3. That's the coordinate for Q. Okay, so it's not too bad really. As soon as you've got the idea that the equation of the line from P to M is going to start at P and go in the direction vector of the perpendicular to the plane, and then solve the intersection with the plane and that vector and double that value of lambda, then you're there. Okay, so it's not too much computation there. Alright then, so have plenty of practice on exercise 9F. We've got one more video to go before we've completed the chapter, so feel free to have some practice and move on to the next one afterwards. Thanks very much for watching.